Let's start the problem that is based on temperature, stress and strain. You know that if the specimen which is heating, the specimen will extend, and due to decreasing the temperature, it will be contraction. Means expansion will occur due to rise in temperature, whereas the contraction will occur in the specimen due to fall in temperature. Then due to rise or fall in temperature, that is said to be increase. That is said to be the stress generated in the specimen. Then today we see some numericals based on the concept of temperature, stress and strain. The first problem, a rod is 2 meter long at 10 degrees Celsius. Find the expansion of the rod when the temperature is raised to 80 degrees Celsius. If the expansion is prevented, find the stress in the material. Take E is equal to 1 into 10 raised to 5 Newton per mm square, and sigma and alpha, that is equal to 0.000012 per degree Celsius. Means in this problem, length is provided 2 meter, then convert into mm, 2 into 10 raised to 3 mm. Then temperature, initial temperature 10 degrees Celsius and final temperature 80 degrees Celsius. Change in temperature, that is final temperature minus initial temperature. Young's modulus of elasticity is given. Then coefficient of linear thermal expansion, that is also given. Then to find out change in length and how much stress induced in the material. Then first of all, given data, length is given 2 meter, 2000 mm, because 1 meter, that is equal to 1000 mm. Next, temperature T1 is given 10 degrees Celsius, T2 is given 80 degrees Celsius. Then change in temperature, change in temperature, T is equal to T2 minus T1, 80 minus 10, that is 70 degrees Celsius. Then Young's modulus of elasticity is given 1 into 10 raised to 5 Newton per mm square. Then alpha is given 0.00000012 per degree Celsius. Per degree Celsius. Then to find expansion of rod, to find expansion of rod delta L and stress induced in the material. How much stress induced in the material? Very simple way to calculate expansion of the rod, that is change in length, and how much stress induced in the material, that is sigma. The first of all, to find change in length, delta L, that is equal to very simple formula, L alpha T, L alpha T. Put up the value 2000 into alpha 0.0002 into change in temperature 70. Then we just do the simplification. Then we get 1.68 mm. After simplification of the given relation, that is delta L, that is equal to L alpha T. We easily calculate change in length delta L. The value will get 1.68 mm. Then find out sigma alpha T into T. We put up all these values. P is 7, P is 1 into 10 raised to 5. Then we can easily calculate sigma, that is the stress, means how much stress induced in the material. Then that value will get 84 Newton per meter square. Then nature of stress will be compressive if the expansion is prevented at both ends. Very simple way. Suppose a specimen is provided in the problem having a length 2 meter. Both the end of the specimen which is fixed, if the initial temperature of the specimen, that is 10 degrees Celsius, then it will be rise up to the 80 degrees Celsius. Then what will be the elongation of that specimen will be generated, as well as how much stress will be generated. Means in this problem we have to calculate the extension or elongation of the specimen, that is change in length, that is delta, and another things, how much stress induced in the specimen or induced in the material of the specimen, that is sigma. Means that the two things are very important according to standard relation. Delta L, that is equal to L alpha T, and sigma, that is equal to alpha T. We can use both the relation for finding out the known values of delta L as well as sigma. After getting the values of delta L and sigma, then which type of the stress induced in the material? Particularly the specimen which is fixed at both ends, temperature will rise up to 80 degrees Celsius. We know that the stress will be generated in the specimen, and it will oppose, it will resist by two fixed end supports to the specimen. Means that stress will be generated in that specimen, the supports will be prevented, means that supports prevent for expansion of the specimen, and the compressive stress will be generated in the specimen. Very simple way, if the two supports are provided to the specimen, if the temperature will rise, what will happen? Stress will be generated. Means that the specimen will expand along the direction of length, and that two supports will resist to the expansion of the specimen, which means that which type of stress generated in the specimen? That is compressive stress will be generated in the specimen. Nature of stress, that is compressive stress. Clear? Very simple way to calculate delta L and sigma. In the same way, we find out some more example. We take another example, very simple way to calculate the known things. Let's start the next example. A steel rod, a 15-meter long, is at temperature of 15 degrees Celsius. Steel rod is given, then temperature is 15 degrees Celsius. Initial temperature is represented by T1, small T1, 15 degrees Celsius. Find the pre-expansion of the length when the temperature is raised to 65 degrees Celsius. This final temperature, that is T2, is given 65 degrees Celsius. If the initial temperature of specimen is given T1, then the temperature will rise or increase simultaneously. What will happen? That temperature will rise up to the 65 degrees Celsius. What will happen? The expansion of the specimen will occur. The specimen or the body will expand if the rise in temperature. Find the temperature stresses when the expansion of the rod is fully prevented. Means prevented, which means that we provide two supports to the specimen, because that support prevents the expansion of the bar of the specimen. If we provide two supports, what will happen? If the temperature will rise, that supports will prevent the pre-expansion or expansion of the specimen. Then take alpha, coefficient of linear thermal expansion. The value is always constant, 12 into 10 raised to minus 6 per degree Celsius. The value of E is also constant. E, which means that Young's modulus of elasticity, that value will be 2 into 10 raised to 5 Newton per mm square. That value is always constant. If the value of Young's modulus of elasticity is not provided in the example or problem, suppose that value always assume 2 into 10 raised to 5 Newton per mm square. That is a constant value of the Young's modulus of elasticity. And the value of coefficient of linear thermal expansion alpha is also constant, 12 into 10 raised to minus 6 per degree Celsius. Then whatever information you have to provide it in the problem, then according to that information, which formula is applicable for calculating the known things in the problem. In this problem, the data or information is provided, that is length of the specimen is given 15 meter, that is 15 into 10 raised to 3 mm. Second thing, initial temperature, it is represented by T1, that is 15 degrees Celsius is given. The final temperature, that is T2, that is 65 degrees Celsius is given. The change in temperature, we take difference between the final temperature and initial temperature. We find out the change in temperature, that is T. Then Young's modulus of elasticity is given. Then alpha, coefficient of linear thermal expansion, that value is always given. To find the expansion of the rod, delta L, and how much stress is generated in the specimen, that is sigma. The nature of stress induced, that is the compressive stress, we already discussed in previous example. If the two supports which are provided to the specimen, and that supports prevent the expansion of the bar, and the compressive stress will be generated in the specimen. Then in the diagram or in the problem, whatever information you have provided, length is given, length. Next, temperature T1, 15 degrees Celsius, T2, that is 65 degrees Celsius. Change in temperature, T2 minus T1, 65 minus 50, then you will get 50 degrees Celsius. Then E is equal to 105 Newton per mm square. Then alpha is given 12 into 10 raised to minus 6 per degree Celsius. To find delta L and sigma, very simple way to calculate change in length. Then first we calculate delta L alpha T, we put all these values 15 into 10 raised to 3 into 12 into 10 raised to minus 6 into 50. Then we find out delta L, that is 9 mm. Once we calculate delta L, then find out stress sigma alpha T. These are very important formula for finding out the change in length, means expansion of the bar, that is delta L. That formula is L alpha T. L is the length of the bar, alpha is coefficient of linear thermal expansion of the bar, and T is a change in temperature. It is represented by small t. Then delta L means L alpha T. Okay, that is said to be expansion of the bar. Then how much stress induced in the material of the specimen? It is represented by particular formula sigma, that is equal to alpha TE. Alpha TE, we put all these values alpha 12 into 10 raised to minus 6 into T is 50 into E is 2 into 10 raised to 5. Then we can easily calculate sigma. That value we will get 120 Newton per mm square. This is the value of sigma. Sigma, which means that how much stress generated in the specimen. Then the nature of stress, finally nature, that is compressive stress. Suppose this is a specimen, okay, like this specimen, then reactive force, what will happen? That is in opposite side, the two forces resist, means the compressive stress will be generated. That stress will be prevented by the two supports, and the nature of stress induced in the material, that is a compressive. This compressive force will be generated in the specimen. Okay. Very simple way to find out the temperature stress, elongation of the bar. In the same manner, this is then next concept we study strain energy. Strain energy means when body is subjected to gradual, sudden or impact load, the body deform and work is done upon. There are three: suddenly applied load, gradually applied load, and impact load or falling load. There are three types generally. Load applied. Load means external force acting on body, that is said to be load. Means suddenly applied load on that object, gradually applied load on that object, or falling load on that object. Then what will happen? The energy will be generated. Means when the body is subjected to any kind of load, there are three kind of load from subject point of view: gradually applied load, suddenly applied load, and impact load or falling load. When the body which is subjected to either any kind of load, what will happen? The body deformed and work is done upon. Body will be deformed. Suppose I am the human body and some load is put on the head. What will happen if the load is increasing? If the load is much from my capacity to sustain, what will happen? Body will be deformed. That is change in length or change in shape of the body. Means that whenever body which is subjected to any kind of load, either suddenly applied load, gradually applied load, or falling load or impact load, what will happen? The body will be deformed and the work is done upon it. Some work is done upon. If the elastic limit is not exceeded, this is stored in the body. If it is not extended, yes, it is not limited, elastic. What will happen? The body will be exchanged. Means the some work is stored in the body, and this work done on energy stored in the body, strain energy. That is said to be strain energy. Means that if the elastic limit is not exceeded, suppose I am the human body and some load is put on my head, what will happen? If the load will rise gradually, applied that load, what will happen? Some energy induced in that body, some energy stored in that body. Now the elastic limit is not exceeded. Means elastic limit is not exceed. It has certain limit. What will happen? Some energy stored in that body. That energy is said to be strain energy. Whatever, I will repeat once again, whenever body is subjected to any kind of load, either suddenly applied
ए
load
माइक बंद करे
or
शनी.
gradually applied load or impact load or falling load, what will happen? The body will be deformed. Work done upon it. The elastic limit is not exceeded. Within the elastic limit, what will happen? Some energy, some work which is stored in that body, and that energy is said to be strain energy. Yeah. Then there are three applications of the load: gradually applied load, suddenly applied load, or impact load, or falling load. Impact load is also called as falling load. What is the suddenly applied load, gradually applied load? Suddenly applied means it is a type of load in which load is applied on the bar from zero and slowly increasing. Means that load will start from zero and gradually or slowly increasing. That type of load is said to be gradually applied load. Means that initial stage, that load will be zero and that load will increase gradually 0, 1, 2, 3, 5, 7, 8 kg. Gradually, that type of load is said to be gradually applied load. Next, suddenly applied load. When the load is applied suddenly, the value of load is prone to deformation. That is said to be suddenly applied load. And impact load means we take hammer at particular distance, then hammering on some material or body. That is said to be impact load. Impact means falling load. We take hammers at certain distance and that load act on that any kind of object. That type of load is called as falling load or impact load. That is the application of the load. Gradually applied load, suddenly applied load, and impact load. Okay. In the next chapter, we will discuss elastic constant. There are three types of elastic constant: modulus of elasticity, Young's modulus of elasticity, and shear modulus. Thank you for that.